So this is session number 4 for friction. So we will discuss few more examples today, and then we can move on to discussing any doubts and questions that you have, because we have mostly done with the concepts based on friction. So one important type of situation we'll discuss in friction, important type of example, is called the two block problem. So basically it's like this: blocks kept one on top of the other, such that there is some kind of friction between the two blocks. That is, the upper surface of the larger block has a particular coefficient of friction with respect to the block on top of it, whereas the ground in this case is smooth surface. So this horizontal surface on which the system is lying is a smooth surface. So let us say this coefficient of friction is 0.2 and the masses given are 5 kilograms and 15 kilograms. Now the system is at rest initially on the ground. Okay. If we start pushing the lower block with a certain amount of force horizontally, we have to find out what kind of acceleration the system will have. That is, what kind of acceleration individually the blocks M1 and M2 will have if we start pushing this with a certain external horizontal force. So find the accelerations of the blocks. So the first case we'll take is when the magnitude of this force is 20 newtons. Second case we'll take when the magnitude of this force is increased to 50 newtons. So just make a note of the data of the question, then we'll start discussing. Okay, so let us start by understanding the free body diagrams when this kind of force is applied, and from that we will understand what kind of acceleration is possible for the system and whether or not it is possible for the system to even remain at rest. Okay. Okay. So what happens here is that the moment we apply this is a smooth surface. So the moment we apply this force to this block, the tendency to slip, that is such that, so how do we understand the tendency for slipping? Suppose there was no friction, then how the motion would be? So suppose there was no friction, then on applying the force to this one, M2, M2 would just start moving like this, whereas this would remain at rest. That is, suppose there was no friction. Okay. So the tendency for slipping would be that M2 tends to slip forward or towards right with respect to M1, because M1 tends to remain at rest and this one tends to slip in this direction, slipping tendency. Okay. So that automatically implies that M1 tends to slip backwards, that is towards left with respect to M2. That is, if this block starts moving like this and you are in this one's frame, this block being at rest, to you it will look like it's slipping towards the left. Okay. So with respect to the lower block, the tendency for the upper block slipping is towards the left. So what will happen is friction will oppose this tendency. Friction acts to oppose the tendency to slip. Okay. So in reality, what will happen is that the moment we apply the actual FBD, this was just the tendency to slip. But in reality, there might not be any slipping actually, because friction is able to prevent slipping. So what will happen is that the moment we apply this horizontal force on it, friction will act backwards on this because it has a tendency to slip forward, and equal and opposite friction will act forward on M1. Okay. So because okay, so friction acts forwards on M1 to oppose the tendency to slip backwards. And backwards on M2, again to oppose this tendency to slip forward. Yes. Okay, so as a result of that, what will happen is that this block will have some forward acceleration. This block will also have some forward acceleration. So as a result of applying the force, there is a friction that acts on M1. So M1 cannot remain at rest. The moment we apply some force, M1 also has to start moving. Now obviously M2 will be moving because there is no friction on the ground. So on application of F, M1 starts accelerating forward at A1. M2 starts accelerating forwards at A2. Okay, so just make a note of this, then we'll discuss further. Yes, that is what friction does, ना? देखो अगर friction नहीं होता सौम्या, then what would happen? M1 would remain at rest, ना? And M2 would just slip from below. So with respect to M2, M1 would slip backwards. So friction has to oppose that tendency, of slipping. So it has to act on M1 in the forward direction. So it has to start moving. If you imagine this also, na, there is friction between the two. When you apply a force on the lower block, the upper block will have to move along with it because there is friction. Friction is not allowing M1 to remain at rest. Okay. Now let's discuss about slipping. So now there are two possibilities here. Okay. If friction is able to prevent slipping, between M1 and M2, that is static friction, then E1 must be equal to A2. Okay, that is, they will move together. So there is no relative motion or slipping. And on the other hand, if friction is unable to prevent slipping, because F is too large in magnitude, so kinetic friction acts between them such that E1 will not be equal to A2. In fact, E1 will become smaller than A2. It is there is relative motion or slipping between them. So these are the two types of motion which are possible. There is no third possibility. It cannot happen that one of the blocks remains at rest while the other one moves in this scenario, because there is friction between the two blocks and no friction on the ground. And definitely cannot happen that both the blocks will remain at rest in spite of applying force, because again there is no friction on the ground. So there are only two possibilities. Ya to the two blocks are moving together like one common block with no slipping between them, or the lower block, because you are applying too much force on it, is slipping faster. The upper block will also be moving, but it will be moving slower with respect to the lower block. So A1 will be less than A2. So make a note up to here. Then we'll discuss how to gauge that in the given problem, which of the two possibilities is happening. Are they moving together without any slipping between them? Or are they moving as two separate blocks with slipping such that A2 is greater than A1? Okay, so you finished writing this down. So now let us understand the detailed free body diagrams. And from that we will understand which of the two is happening. Okay, so the detailed free body diagrams are like this. The lower block is the upper block. So actually they are in contact like this. Smooth horizontal surface. We are applying a force like this. So this was the situation. So if you look at the detailed free body diagrams individually, we will now understand that weight, weight, some kind of normal reaction, one normal reaction acting down on this, another normal reaction acting up from the ground. These are the vertical forces. So these are just the vertical forces so far. We're making it an inertial ground frame. Now horizontal force. So the moment I'm applying this horizontal force here, as we've discussed, friction will immediately start acting without fail backwards on this block and forward on this block. Okay. And in the process, what will happen is this block has a forward acceleration A1, let's say. This block has a forward acceleration A2. नहीं, A1 A2 opposite direction में क्यों होगा सर्वेश? How is it possible? Tell. See the direction of force ना. अरे why will friction start making them move in opposite direction? मैं force नीचे वाले block पे लगा रहा हूँ, तो friction will try to make the upper block move along with it ना. Why will it make it move in the opposite direction? Does it make sense? You tell me. तुमने force नीचे वाले block पे लगाया है and both of them start moving in the opposite direction. Just think logically, no? That's not possible. That is why I made you write down the two possibilities. ना ऊपर हमने लिखा दोनों possibilities. या तो दोनों साथ में move कर रहे होंगे, so A1 is exactly equal to A2, or they will be moving with different acceleration such that A2 is greater than A1, but the direction of the acceleration we've already seen. Na? In this diagram, we've seen the direction of the acceleration is forward for both of them. So the only question is that is this case happening that A1 is equal to A2, or is this case happening is that A1 is less than A2? So that is what we have to analyze for each of the cases. Okay. So now in this, let's look at the vertical forces first. So we know that N1 is equal to M1G, which is equal to 50 newtons. N2 will become N1 plus M2G, which is basically the combined weight. So 15 plus 5, 20 into 10, so 200 newtons. We're taking G as 10 meters per second square. So we can also see that friction's maximum possible value will be mu N1, which is 0.2 into 50. So that is 25 newtons. So maximum friction available to me, limiting friction, is 10 newtons. This is limiting friction. Okay. So because this is 10 newton, in fact, let us start our problem with a different part where the amount of force we are applying is even less than this. Okay. So just give me a moment. We will change the question slightly. We'll keep this as the second and third part. The first part, we are applying a force which is even lesser. Let's say we are applying a force of 5 newtons. So let's see what happens in this case. So now in the first part, F is equal to 5 newtons. We want to find E1 and E2. So now what is the job of friction? What friction wants to do? It wants to make A1 equal to A2. It doesn't want to make A2 equal to 0. Okay. So even though the force we are applying is 5 newton is less than the maximum friction 10 newtons, it doesn't mean that 5 newtons of friction will act over here. Because if you assume that 5 newtons of friction is acting, then the lower block should come to rest, but the upper block should start moving. So that doesn't make sense, na, that we are applying a force on the lower block, whereas the upper block starts moving and the lower block remains at rest. So friction's job is not to bring the block to rest. Friction's job is what? To make A1 equal to A2. So that is what we have to understand. फ्रिक्शन का प्रायोरिटी क्या है? स्लिपिंग को प्रिवेंट करने के लिए. सो फ्रिक्शन opposes slipping such that it tries to make the blocks move together. That is, A1 is equal to A2. And if this happens, static friction will be acting. Whereas if slipping occurs, friction cannot prevent slipping, then E2 will be greater than A1 and kinetic friction equal to mu N1 or kinetic friction equal to 10 newtons will act. Okay. So how do we understand which of the two is happening in this case? Okay. So for that we have to again rely on the free body diagrams and solve to understand is it possible that E1 is equal to A2 when the force is 5 newtons. So in this diagram what we have to understand is that for F is equal to 5 newtons, okay, you have to check if E1 equal to A2, that is no slipping is possible. So how to check that? Let's understand that. Assume A1 is equal to A2, equal to some A, suppose. That is no slipping case. Then F minus static friction is M2A, that will become the equation for this, and static friction is equal to M1A, that will become the equation for this. So solving these two, you will get this equation. So this acceleration will become F divided by M1 plus M2. So remember, we are in the first situation where F is 5 newtons. So it will become 5 divided by 5 plus 15, or 5 by 20, or 0.25 meters per second square. Now from equation 2 you can see the static friction required. So that will become 5 kilograms multiplied by 0.25 meters per second square. So the static friction required will become 1.25 newtons. Okay. Whereas we know maximum friction available is equal to 10 newtons. We have already seen that before. That is mu n1. So therefore, the assumption of no slipping is correct. Okay. So in this case, E1 will be equal to A2, will be equal to 0.25 meters per second square, and static friction of 1.25 newtons act between the two blocks. So basically you can say in this case what is happening is friction is successful in its job to try and prevent slipping, because the amount of force we are applying, 5 newtons, is comparatively less. So friction is able to make the two blocks move together without slipping. Okay. So just make a note of this, then we'll discuss the second case. In fact, now based on the same method, after noting this down, you can try working the second case out yourself. In the second case, we are increasing the force to, how much was it? Increasing it to, I think, 20 newtons. Yeah. So what is happening is, because we know a maximum friction of up to 10 newtons is available, therefore we know that this is possible. So we know that the assumption is therefore correct. It's a true assumption because we have enough friction to support the assumption. Okay, so hope this is clear over here. So make a note of this and now apply this exactly the same method and try to figure out what is happening in the case B, where the force we are applying is increased to 20 newtons. Yes, Soumya, that's also correct. Second part also, the acceleration will be common. Okay, A1 will be equal to A2, and that will be equal to how much? 1 meter per second square. Varun, that's correct. Very good. So same free body diagram, same assumption, but it will give you the slightly different result that the acceleration, common acceleration is 1 meter per second square, and the amount of friction acting will therefore be 5 newtons. Okay. So if you worked out the second part, now you can start doing the third part where we increase the force to 50 newtons, 50 newtons. And for others, you can just follow what I'm doing. So in this part, we have increased the force to 50 newtons. Whereas we know that maximum friction available to us is 10 newtons. Okay. So let's again check for the no slipping condition. What is the condition for no slipping? Okay. So for that, we just assuming A1 equal to A2 equal to some common acceleration A. So F is equal to M1A, capital F minus F is equal to M2A. So solving these two give us that same result, that A would be equal to F upon M1 plus M2. Only this time that would be 50 newtons divided by 5 plus 15. Oh, sorry, my mistake. That's the third part. I'm doing the second part. Those who have finished the second part, you can move on to the third part. Second part में कितना था ये 20 newtons. So the common acceleration would be 1 meter per second square. Now for A equal to 1 meter per second square, friction required is equal to M1A. So that is equal to 5 newtons. This is the amount of static friction required because the two blocks are at rest with respect to each other. So it is static friction. It's not kinetic friction. So this we have to now check against this. So we can see that yes, this is very much possible. So since maximum static friction of up to 10 newtons is available, okay, therefore assumption of A1 equal to A2 is true. So therefore for F equal to 20 newtons, A1 will be equal to A2 will be equal to 1 meter per second square. There is no slipping between them. Okay. And static friction of 5 newtons will act between M1 and M2. So that becomes the final answer. So take this down if you haven't done this, and now move on to C part where we are increasing the force to 50 newtons if you have completed this part before. Yes, very good, Swami. That's correct. So now think that अगर ऐसा हो रहा है, this is what is happening, then what will be the final assumption? What will be the final conclusion for A1 and A2? For the C part, just work that out now. So it is like if friction is not able to do its job, then what is going to happen? A2 will be greater than A1, and the friction acting will be kinetic friction. So now solve the free body diagram with that assumption that the friction acting is kinetic. So Sarvesh, you're saying they will have common acceleration in the last part. Okay, so you start with the same method, that assume there is common acceleration and check out how much friction is required. But this time when you check out how much friction is required, you will see it will exceed 10 newtons. So that means that much friction is not available to you. So that means the assumption that there is no slipping is incorrect, which means that there is slipping. So you start by the problem by again assuming no slipping condition. Okay. So A1 is equal to A2 equal to A, that we are assuming. Then we have the same equations. F minus friction is equal to M2A. Friction on the above block is M1A. So solving A comes out to be F upon M1 plus M2. So it comes out to be 2.5 meters per second square. And friction required, which is M1A, this time it becomes 5 into 2.5. So 12.5 meters per second square. Now you see this assumption has failed. This is not possible because maximum static friction was mu n1, which was only 10 newtons. So that means our assumption is wrong. Therefore, assumption of no slipping is false. Okay. Because F is too much. You have too much of magnitude of force. So that means A2 will be greater than A1. That is, slipping will occur. Okay. And the friction acting will be kinetic friction. That will be mu n1. So now we will apply this condition on the free body diagram. So now we will apply this here. Okay. So from that find out how much will be A1, A2. Very good, Rahil, that is correct. So A1 will be 2 meters per second square and A2 will be 2.67. So now we have to basically just resolve this free body diagram with the assumption that friction is kinetic. We have to do this, okay? So capital F minus kinetic friction is equal to M2A2. Okay. So kinetic friction, remember, will be this mu N1. So that will be 10 newtons. So 50 minus 10 will be equal to 15 A2. So our A2 is becoming 40 by 15 or 8 by 3, or as you correctly said, A2 is 2.67 meters per second square, and kinetic friction is equal to M1A1. So 10 newtons is equal to 5 A1. So A1 is equal to 2 meters per second square. So as you can see that A1 is not equal to A2, and the friction acting is kinetic friction equal to 10 newtons. So that becomes the final answer. Okay, so hope this is clear to all of you people. So we are more or less done with friction. Now I will discuss some of the specific questions from HC Verma first. Okay. So next I will discuss um, an identical question to the one given in HC Verma, only the values might be slightly different. So you have this situation that on an inclined plane, you have kept a combination of two blocks, and they have different coefficients of friction because the blocks are made of different materials. So as the combination of blocks comes sliding down the inclined plane, we have to find the accelerations and the contact force. Yeah, uneven surfaces is what we are discussing. There is nothing more than this, okay? So pay attention to the question I'm giving next. So they are initially placed in contact with each other, okay? So blocks M1 and M2 are placed in contact and released from rest initially, okay? So given that M1 is 10 kilograms and its coefficient of friction is mu1 equal to 0.3, let us say, okay? M2 is 5 kilograms, but its coefficient of friction is 0.2. So the blocks are made of different materials and therefore have different coefficients of friction. Take G as 10 meters per second square. So we have to find accelerations of the blocks, okay, and contact force between the blocks, okay, if any. Okay, take down the question, then I will discuss something about it and you will solve it yourself. Okay, so let's understand how we will analyze the problem. So one thing to keep in mind is that something we already know, that if we have just a single block, okay, on a surface of angle theta, and this coefficient of friction is such that mu is less than tan theta. So if mu is less than tan theta, we know that the block accelerates. If mu is greater than equal to tan theta, then the block remains at rest. Okay. And we also know that if it accelerates, the acceleration will be equal to this value, g sine theta minus mu cos theta. This we had learned very early on in friction. This is mu kinetic only because there is one common value of mu. Okay. So importantly, you can see that if it is accelerating for this condition, then its acceleration A is independent of mass. Why? Because the normal reaction also depends on mass. So mass cancels out. Okay. So the acceleration depends only on coefficient of friction and of course theta. So mu जितना ज़्यादा होगा acceleration उतना कम होगा. So this is the key thing we have to understand. So with this thing we understand that when we release the block, here what is happening, mu1 is also less than tan theta, mu2 is also less than tan theta because tan theta here is 0.75, tan 37, 3 by 4. So both have a tendency to accelerate. Okay. That is the first thing. Secondly, since mu1 is larger than mu2, so m2 has a tendency to accelerate faster. मतलब अगर if we had released the blocks with some distance between them, then this one would have accelerated faster. So that means what is happening? It means that m2 pushes m1 as they are sliding down. Okay. So it is with this simple fact we realize this, that they are going to move together because m2 will tend to move faster. So it will come down the plane pushing against m1. Why? Because of this fact. Because mu1 is greater than mu2. Mu1 0.3 है, mu2 0.2 है. So if you had released the blocks with some gap between them, then m1 would have accelerated slower, m2 would have accelerated faster. So since you are releasing the blocks with no gap between them, m2 has a tendency to accelerate faster, so it comes down the inclined plane pushing on m1. You understood this point? So the moment you realize this, it becomes very easy to solve the problem because you know that one block is pushing against the other and therefore they are moving with the common acceleration. So next we will solve the problem with that assumption, okay, or with that result in mind. Okay, it pushes m1 and so they come down sliding together with common acceleration. Okay, so just note down this part, then we will solve this with the FBDs. We will solve the FBDs with this assumption in mind. Okay. So next, let us look at the full solution. So we know that because mu2 is less than mu1, this block will be pushing against that one. So M2 will apply a downward pushing force on M1, and M1 will apply an equal and opposite upward pushing force on M2. So there will be a contact force between them, like this. Okay, and of course friction will be acting on both of them up the inclined plane. So यहाँ भी kinetic friction, यहाँ भी kinetic friction. Okay, and of course weight and normal reaction. So they will have the common acceleration E, let us say. Okay, here I'll take you back. Just first let's complete the free body diagrams. Okay, so individual free body diagrams, if we look at on M1, what all forces are acting. So I will just resolve the weight and all that. Okay, so I'll write everything in resolved form. So there is M1G cos theta, M1G sin theta. Okay, then it is getting pushed down with some normal reaction N. Okay, then there is some friction acting on it, which is mu1 N1. Okay, because the normal reaction of this block from the ground, I mean from this surface, is N like this. Okay, so under the action of all these forces, it has an acceleration E. So this is M1's free body diagram in inertial frame, the ground field. Okay, so what are the equations I'll write? N1 is equal to M1G cos theta. Okay, now M1 was 10 kilograms, M2 was 5 kilograms, mu1 was 0.3, mu2 was 0.2. Okay, so this is 100 into cos 37, theta was 37, so 80 newtons. Okay, and we will have m1g sin theta plus n minus f1 is equal to m1a. So this equation, okay, will give us 60 plus n minus, now this friction is mu1 n1. So mu1 is 0.3, n1 is 80, so 24 is equal to 10e. Okay, so this is our first important equation. That is 36 plus n is equal to 10e. So next what you do is you make the free body diagram for this block, for the M2. Next you make M2's free body diagram, okay, and write a similar equation and solve for E and N. So try this out. Okay, so anybody's got the answer? So देखो, on the upper block M2, now इसके लिए weights components are going to be so this one is going to be 30 newtons and this one is going to be 40 newtons because its mass is 5 kg. Then normal reaction N2, this will also become 30. Now on this is pushing back. The lower block is pushing up with N and there is kinetic friction, so that is mu2 N2. And it has the same magnitude of acceleration as the first one. Same acceleration, common acceleration. Okay. So we have N2 is equal to m2g sine theta. So that is telling us that N2 is equal to 30 newtons. Okay. So that is also telling us that friction okay, so that is mu2 N2. So the friction acting is 0.2 into 3, so that is 6 newtons. Okay. Now the second thing is m2g sine theta. Sorry, this is cos theta. That's correct. The value I've written is correct. Okay. Yeah, this one will be 40 and this one will be 30. Okay. Yeah, so I'm just showing you the values. Okay. So this now this time minus n minus f2 is equal to m2a. So this equation will become 30. This friction will change. This friction will be how much? This normal reaction is 40 newtons. So this friction is 40 into zero point 0.2. So it's 8 newtons. So minus n minus 8 is equal to 5a. So this is becoming our second equation. 22 minus n is equal to 5a. Okay. Now we can just add the two equations to get the acceleration and then substitute to get n. It looks like there is some mistake here because I'm getting n with a negative sign. Shouldn't be getting n with a negative sign. Oh, sorry. I've calculated the acceleration wrong. Not 36 plus 12, it is 36 plus 22. So it is 58 by 15. So this is a more complicated value of acceleration. So this will become 3.87 meters per second square. And accordingly, normal reaction I will get as 2.67 newtons. So these will become my answers. So yes, I think Rahil, you are the one who's got this answer. No, Varun. Yeah. So Varun, your answer is correct. Okay, so just go through the solving part first, then I'll take you through the explanation once more from above. Okay, now we will solve a second part of this question. This was the first part, suppose. Now we will solve the second part if mu1 is instead 0.2 and mu2 is 0.3, whereas m1 and m2 are the same. Okay. Again, find accelerations and normal reaction, if any, between the blocks. Now, the second part is much easier. If you just understand the explanation I've given you on the side here, you will realize how to solve the second part. So just try this out. Yes, so that is a correct answer, Rahil and Varun. So in the second case, what will happen is that, so in this case now, because now mu1 is less than mu2. Okay, so the lower block m1, it accelerates faster, so they lose contact. Okay, so normal reaction becomes zero. The two blocks lose contact. So after a while, uh, they're moving like this. Because E1 becomes greater than E2. So E1 becomes G into sine theta minus mu1 cos theta. So it becomes 10 into 0.6 minus 0.2 into 0.8. And E2, and contact force between them is zero. So there is no contact force. There is only weight, this normal reaction, and friction acting on this block. And similarly on the second block, there is only weight, friction, and normal reaction acting. Okay, so this is one of the standard type of questions in HCV. So hope this question is clear. Before we conclude, just one more thing I wanted to tell you about is, if we have a situation where, because this is a rough surface, okay, on application of some force like this, there is a combination of friction and normal reaction acting. Now sometimes you are asked to calculate the net contact force on the block due to the floor. Okay. So this net contact force is basically what? It is the vector sum of friction and normal reaction. Okay. Because these are both contact forces. Okay. So whatever the friction be, it could be static, kinetic, whatever. And whatever the normal reaction be, it could be equal to the weight. In a different situation, it might be more than less than weight also, depending on external forces. But their vector sum, suppose R. So R here is the net resultant contact force. Okay. And R is equal to square root of N square plus friction square, because they are perpendicular to each other. Always normal reaction and friction will be perpendicular. Okay. And suppose R is making an angle theta with the vertical, then you can see that theta is tan inverse of friction by normal reaction. Okay. So there are some questions in HCV in the beginning where you might be asked to calculate this. So you should know how to calculate this. Okay, so people, hope this is clear to you. So now you're in a position to finish friction from your module as well as from HC Verma. And since you have a break coming up, so you can invest a little bit of time from that break. Enjoy your vacation with family also for Diwali, but you can invest a bit of time from that to complete friction or anything else pending from earlier, Newton's laws of motion, or in case anything is pending from vectors. Okay. And while going through all that during the break, if you have any doubts, please keep them noted down so that immediately in the next doubt session or mentorship session you can discuss that with me. Okay. So that's it for today's class, people. Wish you all the best and wish you a very happy Diwali and prosperous year ahead. Very crucial year for your studies coming up, but most of all, enjoy the festival with your family. Okay. Okay, people, all the best.